Alrighty. Be right back. And back before I try to cover up my slang, and this is for Decatur. What's up, Bobby Ray? So can I get a wish into politics? Oh, whoops. Wrong thing. Um, hmm, hmm, hmm. All right, so let's just maybe upgrade Visual Studio while we're doing this. It shouldn't be famous last words, but I feel like it shouldn't be a big deal to upgrade this. I feel like it's going to be pretty straightforward, actually. Maybe not, though. Okay. Let me close out here. See how fast it's going to be. Should be relatively painless here. Let's talk about day 15 goals. So basically, last time we got into blocks and structure and stuff. So let's see. What's up? So today, I guess we're gonna get into chunk building, chunk rendering. We'll put we haven't made it super far, but we've gotten into voxels. Yeah, you know, right in the middle there, I turned a lot of kind of voxel based discussion points into actual discussions. And that's good, but more talk, less programming when that happens. And so, yeah. That's basically, it kind of stalled us a little bit. We also ran into some technical things, but no big deal. I think we're ready to move forward with a lot of this stuff. So I had these goals. We'll keep that current goal list and see how close we can get to that. My dog's gonna be annoying me the whole time, I guess, because I have food here. So last time we went over, we have our block. We used like a struct layout with a 2-byte aligned pack. Let's see. We talked a lot about this. So I'll briefly go over this. Basically, we kind of found like via trial and error and using like a disassembler to kind of view the assembly that was being generated for a lot of this stuff. We were trying to figure out the best way to allocate chunks and not put so much pressure on the heap. Now, that can be good and bad, right? I mean, if you put a lot of pressure on the heap, then then garbage collection is gonna drag, and you're gonna end up with you know, inefficiency in terms of like memory management, and that can be okay in general, but the way we were looking at it was, I think here's what we figured. That's what I need to open. Here's what we figured. Well, I think I have a docs. Yeah. Here we go. So memory expectations. This is kind of what we came up with here. Is that here are theoretical chunk sizes, and this is our world view. Basically, how far do we want to see, and this is all kind of theoretical stuff, and we kind of applied this in a couple scenarios, and this is what we came up with. Basically, we end up with, in our worst case worldview, we end up with 1.4 gigabytes of data in memory just from chunks. Oh yeah. No, I totally remember you, man. Because I've actually clarified this thing. I've actually clarified that a few times, that the way we're looking at voxels is a Minecraft-y block type vision of voxels, and maybe not as drilled down or technical. Yeah, I absolutely. I think that was actually a pretty good point to make. And you know, we haven't really even talked about voxels until about 3 sessions ago, which is funny, but it's we're starting to roll. Yeah, Bloxels. That's a better. You're right. That's a better terminology. But we haven't even mentioned it. We drew a couple outlines and stuff like that, but we haven't even mentioned it until yesterday, or yesterday, 3 sessions ago. We started talking about like how we're going to load these things, like what they're going to look like. We started designing data structures around them. So the thing with this array is what we kind of concluded was, well, all right, there's pretty much 3 types of array. There's 3 approaches to an array in C#. Is one, we can use like a 3-dimensional, like jagged array, where dimensions don't have to be equal and stuff like that. Basically, it's just an array of arrays, right? Oh, nice, man. Hopefully exams went well. I was never a good student, so so exams were a very stressful time for me. I mean, they're stressful for everyone, but for me specifically, it was. So basically, what we said here is, so okay. There's 3 types. There's the jagged arrays, which are just array of arrays, and since we're pretty sure we want to define dimensions to not be dynamic, we know what our width, height, and depth will be. So those aren't too helpful. However, arrays, are special, and they are stacked data types basically that you pass by reference, right? They're like special in that regard. So that's a handy feature to have. And then we looked at the multi-dimensional C# arrays. Oh, nice, dude. Hey, dog, please come on, cut me a break. Trying to combine too many things into one. Trying to eat and stream. Sorry, it's not super professional here. Basically, what we kind of came down with is, and the third way is to use a single dimensional way. So the multi-dimensional arrays actually allocate everything on the heap, which was a little bit startling, but also not like a huge surprise, I guess. So we came up with kind of this 4th approach, or 3rd approach. So there's also, you can use a 1D array and use like this indexing, which I specified the terms with the parentheses. I don't think they're needed, but I specified this way. Basically, you could use this indexing, and you're guaranteed to have it exact. It's basically just linearly running through these things. It's kind of like how you pull indices out of images. In a lot of cases, you do like a run. You do like a run and a. Please. This doggy. I'm gonna I'll be right back. Come on. This is what I've been missing, is the coffee. I needed the coffee. Yeah, it's not much of an optimization. I think it's more about, and we'll figure out how this works a little bit later, because I mean the arrays in C# are a little weird. I haven't quite figured it out yet. I'm guessing that it has some sort of memory sharing allocation piece under the hood that the runtime uses to kind of like not just blast the stack with data, but it's less of their indexing scheme here is less about optimization, and just more about not allocating everything on the heap. Because if you use a multi-dimensional array, that thing shows up on the heap. And if you use this guy, then it actually doesn't show up on the heap. But what exactly that means, and like we kind of went through this whole thing, and then we kind of were like, okay, then we took a step back and we're like, all right, well look, like stack versus heap is sort of like an implementation detail. It's not really, we shouldn't really be concerning ourselves that much with this, but at the same time, you know, we don't want to be creating a bunch of garbage collection churn this early with just these massive objects. And so I think, at least in my mind, what the goal was is to just kind of remove a huge portion of the heat pressure, at least initially, because if you start thinking about how much data is generated in this for stuff like this, you start to realize, like, not only do we have to represent the blocks in the chunks, and then we have that 1.4 max amount of memory use. We also have to consider mesh geometry for that, texture data. I mean, we're gonna have so much stuff kind of flying around at any given time that we kind of pre-optimized, which is normally not a good thing to do because it just limit your design, but we've kind of pre-optimized a little bit with the expectation that we don't have it right, and we're gonna have to kind of figure it out as we go. Yeah, I mean, clearly you can't do everything on the stack, and again, stack is implementation detail. So we're banking right now on the fact that we know that arrays are special, and that we are going to lean on that specialness of the arrays, and in the hopes that it's going to handle our memory woes. And if it can't, then what we are basically doing is following in our little array 3 here. Where are we? Util array 3. We're just going to follow kind of a simple multi-dimensional array API. And so if we say, look, this thing sucks and it's causing problems, then we can literally just switch right back over to our chunk and flip it to a multi-dimensional array and just and tinker with this stuff. Because at the end of the day, we're gonna back the data. We could choose how we store this data. I mean, we could store it in files if we wanted to, but I mean, clearly that's. I guess the idea though is that we just kind of establish maybe some options early, and then as we kind of progress through this thing, realize the problems, we can change how we're storing it without too much ripple effect in the entire application. Oh man, that's good. I keep all these styrofoam cups from Dunkin' Donuts laying around so I can drink it out of. So you can reuse them. I'm also not super crazy about how we're creating new things pretty constantly, but again, I'm gonna try not to optimize anything right now. I'm gonna try to wait a little bit at least till we recognize problems. At some point also we're gonna have to get this is miserable. This thing was we clocked it a few times and it was slow, to say the least. Okay, so I guess we actually have. So our chunk right now isn't very complicated. It's pretty much just a little wrapper around the array that applies like a world coordinate, and then as you set the block types on the chunk, it's going to set the world coordinate on the block, and it's also going to set that block type, and that's it. So nothing too fancy there. So one of the things, let's go back into like Vrox main here. And given this is kind of where we've done a lot of our basic tests, we can probably I never actually got into creating scenes, but that's fine. We don't. What I really kind of want to do is just start from scratch with like a clean slate in terms of. Yeah, right now we are. We won't need to. We can infer that later, but right now, yes, we are. It's on my list, man. Don't ruin the surprise. Since we're not like writing anything right now, we're not like writing out the files or anything like that. It's just we have it in there for simplicity, so we don't drive ourselves crazy when we're trying to debug this thing. Or at least I'm not driving myself crazy because I can just look at world position and know where I am. But you hit the nail on the head. That's where we will go there. Okay. So what I've wanted to do, what I wanted to do is just create. Yeah, we can do that. We can just create. Let's. This is our fake method here that we don't need. Okay, so we'll just call it chunk, and we'll just pass it 0. Yeah, a lot better. Right, exactly. And you're removing all that from memory. You're removing the whole. Yours basically, your block actually just becomes block type, which is just a byte. So, yes, you're right. It's a lot better. It's Yeah, basically what I was going to get into is that you can we will never almost never will we access a block without the chunk. You know what I mean? Like we always know we're relatively diploiform. So yes, then it becomes a chunk has a world position, and the block position is essentially just the is just the offset. It's just the chunk world plus whatever index in the array you're accessing. But for right now, we're gonna set it because undoubtedly I'm gonna run into issues, and yeah. So trying to think of the best way to just build this kind of in a naive way, and I guess it's just going to be I'm just going to create a bunch of blocks, I guess, that we can put on top of each other. The naive approach is good for the first approach. So let's just add in a knit chunk here. This will probably get, man, my vision this morning is jacked up, to say the least. Yeah, we're just gonna have our little, well, we'll do XYZ. And we'll just I guess we'll make it dirt. X, Y, Z, and then something like that. Of course, you want to float. Some noxious. Wait, can we not do that? Oh, it's expecting a uint. I guess because height is, I don't know. Why was that defalsing to float? Are these floats? What in the hell was that? That var, I was using var here and it was oh, it's converting, it's using an int. I guess that makes sense too. I thought it was using a float, but it was just, oh god, dude, unit testing. Make sure you get your coverage above 50%. Coverage. Get your coverage above 50% before you submit your merge request, please. I don't even know if we want to even, I mean, this is going to be fairly redundant. And super inefficient, but it'll be okay. I guess then we're gonna have our we're gonna have our nice little for loop again, and we shall X, Y, Z. I don't have any accessors, do I, in my chunk? That's probably a good idea to add some. Oh, I have an at. I do not have a multi-dimensional array, but I should probably add that maybe. So we'll just get the block reference. And I guess we'll just do this like, I mean, I really don't want to re-render them over and over and over and over again, or create them and re-render them over and over and over again. Sheesh. Although I guess we could. This is in fact the naive example. And I guess we'll just toss it as well. We'll get to modifying this stuff later, I guess. Block type is not equal to then we shall render. Create cube with normals. And I guess we would do if the minimum's going to be X, Y, Z. So we'd have to do. And I hate the crappy type conversion boxing stuff that we have to do here. It's not going to work, is it? Yeah, it did. Nice. And then oh, we should do it. Gross. Or we should say create mesh, aka 1 bazillion meshes. What is it? X plus Y times width. What was that? What was that tricky array? Actually, it doesn't even matter. We can just plop them in a list. Let's just throw them in a list. Make my life easier. We can at least initialize this. Then we can just add this. And then return. Ugly as can be. Oops. Nope, nothing there. Except for a knit chunk. So this is, I mean, it's kind of stupid that we're initializing it and then creating it. I have a point to that. Let's remove that and then let's gonna have to talk to you. No! It was bound to happen at some point. Gotta find the towel. Rip keyboard. Okay, hold on. Oh man, it's not my fault. It's people who called me. So no, not that much of a mess. I just dumped a little bit of coffee in that keyboard. It's probably going to be done though, but it's not a big deal. I fully expect stuff like that to happen. Happens all the time. This is why I can't have nice things. No, I literally, at one point in my life, I used to want things like a nice keyboard, but I have plenty of spares standing by that are garbage, and we can dump plenty of coffee into them. Yeah. Anyway, so highly inefficient, yet kind of gives us an idea of maybe the CPU tugging power that this thing's going to have. I guess we can use a for each VAO, or we'll say and using Java chunk mesh. Then we shall and I'm not sure. Oops. I actually think that I have to create, I can't do this because my renderer, I need to make this, what do we call it? What did we call it? A renderable? OpenGL renderable? We won't actually do this. We will not render each we're not going to render each individual cube like this. So just bear with me. Listen, if you want to be OCD and nitpick, like there's lots of other things to nitpick other than the normals. But I am fully aware of a lot of this. So whenever you look at me and I say, this is the final, this is where I'm leaving things, then come on with it. Because what? Why is this being difficult? New rocks object, and then this is there. And then we'll add. Oh, it's mad about that still. That's what it's mad about. Okay. Wee. And look how the shading. Look how the shading applies to each individual block as if it was its own entity. And then the best part about this is if we start drilling down in here, all of that is being rendered. All of the faces for all of the voxels, even on the inside, they are being rendered. That is awful. But good. I mean, we have it something that displays. At least we're this far. You hear my CPU, man? Actually, it's not too shabby. But it's also not doing... What is that? Did that say 38%? Why is this profiler so... 38%? Is that really what that said? It's awesome. Okay. Anyway. Clearly not efficient. Good, but extremely awful. So we're doing we're working on like a voxel engine. We started from the pretty much, besides OpenGL bindings and stuff like that, we started kind of at the bottom of the totem pole, and started working our way up. And we're doing it in kind of a way that is probably more natural for programmers, which is a lot more of the like, hey, let's build this, let's make it inefficient, and then like as we go, let's talk about how we can make it better and things we can do to reduce overhead and how to actually write a program from start to engine. So yeah, but I'm not going to correct it every time, just because I don't want to sound like some pretentious jerk who only views things in one way. So I will clarify multiple times though. Because the problems are very similar, and that's at the end of the day, that's what we're looking at. And I mean, who knows? We could take each individual unit and create something else with it. So eventually, this can become a really nice little networking problem, but I will get there as well. So let's So I think ultimately what we want is what I ultimately think we want is kind of a quad generation technique. Now, clearly, for a million reasons, this is not the way you want to solve this problem in a scalable way. One of the bigger issues is that we're creating a bunch of these, and we don't need to. And a bunch of rocks objects as well, which have their own set of overhead. Yeah, but that's not what defines them as a voxel. You're trying to lay claim to a term that's super general. And I think you can still use, what's preventing you from using like an octree in with regular block style voxels? That's the question. Because I'm pretty sure what we're going to end up building is a variation of an octree. Or there'll be an octree-ish data structure. I was about to say, thank you, Colt. I was like, that doesn't, like, octree is just a data structure that you could represent pixie sticks. I don't even know why that was my go-to for abstract thing, but right. Oh, you're saying like an unlimited, like an unlimited depth octree, or what? I mean, you could make anything. I could make my blocks octrees, and they could have more detail, and then they could have sub-pixel blocks. I mean, this is what we're talking about is up in the air. I mean, we could make this thing whatever we wanted. We're not really going to have infinite depth. We're just not. So let's think about this. Let's think this is the way I've thought about this problem in the past, and let's just talk about like what this actually means here, and then we'll talk about how we can make it better and faster, and how we can reuse a lot of this stuff, and then we'll move forward. But historically, when you talk about meshing these blocks on, we talk about meshing these blocks, we need to probably think about it in terms of quads. And the way we kind of need to approach it is we need to determine which side, basically for each quad, right? We need to consider six different sides of every voxel, but so 6 quads. But for each block, you can very easily determine if the thing next to you, right, is showing. So like if we move like from left to right, then each pass, it would probably be better just to look like down first and then right, down and then right, down and right, and then jump to ahead or something like that. There's probably a pretty efficient pattern to propagating those things. For general purposes, we're going to start out with like a linear for loop, which is not going to be anything special, but I'm trying to think. Basically, we would just want to consider each side of every cube, and that for right now, it's not that big a deal yet, but it will become when we have chunks that are next to each other. That becomes a little bit of a different problem because now we're having to look at blocks in another chunk. But that's, again, it's not overcomplicated, but it's a different problem because right now we're expecting everything to be local to our chunk. So let's think about this. So quad, six quads per. We could check the direction for each one. And if there's a block that is non-air next to it, then we don't have to render it. And I'm trying to think of the other ways to do this. We're going to want to create one single vertex array object for all the geometry versus multiple ones. Well, I mean, block slide logic is the easy logic. Yeah, I mean, so what I'm thinking is this. Let me just sketch it. We'll make this. We'll sketch this shit. So I mean, basically, we can have like an enum sides. Like we'll just talk about this in very general sense, right? Sides, and we have north, south, east, west, and then front, back, I guess. I'm not really sure the cardinal directions in the 3-dimension. Towards and backward, or towards and behind, I don't know. Front, back, that's what we'll call it. Maybe we should use up, down, left, right. Let's do that. And not cardinal directions. Oops. I like that better. Front and back go better with those. See, look at you, man. We're converted you. We've convinced you. I don't think we've convinced you, but you said voxels. Man, brother. We're making changes here. We're making differences in the world. I'm just playing, man. I agree. By the way, I do agree with you. I think there should be a distinction. I just am giving you a hard time at this point. And I'm going to make the mistake all the time where I call them voxels instead of bloxels. Yeah. Gotcha. And the thing is like this is one of those things that I think we will start out in this sort of pattern where we when we're generating these things, we're going to see like these patterns come up. I think generated is a lot harder to do it because you're having to come up with each thing on the fly. But once you're able to like compress things down into a file format, digging when you start to see like the repetition patterns show up and how to optimize that way, think about when you know everything up front, like via a file format, optimizing what you render becomes an infinitely easier problem, and you don't have to do things like process it again or run all these algorithms. You can basically just store all those shortcuts in your file format. So that part is at least really nice. I feel like we will start to realize as we're writing things out the disk and reading it back from disk, that we're going to have lots of room for optimization. Yeah, good point. I do this all the time, but I'm not sure that the compiler doesn't automatically do that for you. Now, do I need to specifically set the flags, or will it automatically do 0, 1, 2, 4, 8, 16? If I just add the attribute. Something I'm not sure of. Okay. So oops. Now is a byte. Byte's not enough, is it? It's not enough. No, yeah, it is. No, it's not. Byte is not enough. 8 bits. Yeah, it is. I'm thinking of 4. Why am I thinking about 4 bits? It's plenty. Byte is plenty. What am I talking about? I'm literally thinking of a byte like this. As like 4 bits. Why am I thinking about it like that and not an octet? I don't know. Probably the separation, the 4-bit separation. Oh my God. Sorry, my mom and my wife are in a group text and that's getting muted. But we will always have a side, right? We're hoping we will always have a side. Maybe not. Maybe you're right. Well, yeah, you're thinking about this in a little bit more optimized terms again, and that's fine. I'm gonna be a little bit more ugly. Now I do want you to I do want you guys to correct me if you see me write some explicitly non-optimized code that looks like it might be a problem to optimize later. Please do comment. Because the idea here, at least from my standpoint, is that I want to do it in a way that's clear first and then kind of work through that optimization process without having to do a whole lot of API refactoring. So, and a whole lot of, I mean, I really don't want to do any API refactoring if I have to change the way we optimize something. And I know it will, you know, that's kind of inevitable at some places, but I think in general, what I would like to do is be just upfront and clear about everything first, data structure wise, and then kind of peel back layers and optimize. Number one, just for my own personal benefit of doing it, just being able to work through the problems, kind of on the fly, since we aren't really doing any planning. So another thing we could have here, we could have like a static class, and we could call this. See, this is where I start to get a little bit irritated, because everything vector3 in this library is all a float. And that's fine, but integer math is just so much faster. And I keep thinking about position and world coordinates and stuff like that being as simple as like bit shifts. And it kind of makes me want to write like a vec3i or something, like a integer based vector class that's just basic, and then have like a conversion to a float vector. Hey, thank you. That's a great point. I see what you mean now. Although I really think for right now, the way that I'm thinking about this, I think is a little bit different. I'm not sure that something's going to be able to have two sides right now. So I don't even know. And they need to be flags. I mean, we'll make them that way. Excuse me. Well, right now I'm just looking at a side as like a way to query something, or a way to pass kind of, hey, this is a quad for this side. Something like that. Yeah. Well, and so that's kind of where I was going with, because you can do things, right? Especially if we're going to use powers of 2 on this on the chunk dimensions and stuff. You can like move, you can move from world space to chunk space to local chunk space. Like you can use bit shifts for most of it. I mean, it's like, anyway, it doesn't matter. Speaking of over optimization right now, we're really not even. I'm talking. I love that I went through that whole thing about like trying to make it explicit and obvious at first, and then optimizing over here, talking about bit shifting coordinate spaces. So naturally, I think we don't really. I'm thinking of general API, and what we might need. I mean, because I think in general we want something like, we want like a quick lookup for like directions and stuff. So that's kind of what I'm trying to work out in my mind here. So just bear with me here. So we could do, this is kind of why the 0 didn't make sense, right? Because we're always going to have a side. A side will always be a thing. I'm not thinking about it as being a property on something. I'm thinking about it being more or less a queryable thing. Oh God. Don't bust out. I'm just kidding. You can show them. I don't care. It's really pretty neat. I'm gonna just, since I'm kind of prototyping this right now, I'm just gonna do this. I think we'll leave it as 0, but I think ultimately what I want to do is this. If it doesn't need to be sorted, what should I use instead? Let's see here. Hold on. Okay, let's hold on. Oh, I was going to pull up dictionary, but it opened the actual dictionary. I wanted to see the CSharp where it says the requirements for using a dictionary must be sorted, because I really don't think it says that. And I also don't see anything about, like, why would we not want to use a key value relationship here? I'm gonna do it this way. Right, but I'm hashing two unrelated. I'm hashing basically a side into a direction. Would you just assume order and use it as an index? But I can't use it as index because I made them flags. No, I know. So basically we could do actually we wouldn't need to do flags, right? We could just make this a byte and we could just the way that I want to use it, we could just do up equals 0, right? Down equals 1. We could just use a list. Or we could hash the sides into indices. Why does dictionary sort values? What I've read is none of them guarantee order. A hash table uses a rehash for collision, and a dictionary uses buckets. No, but basically what I'm thinking about here is this. It doesn't matter. I mean, if we're into this discussion of over optimization up front. Like we can do it like this. I mean, we as long as we know what each thing is. I'm just trying to be clear here. Is that look, like if we have a byte that's a side, I mean, we can make this a damn array. If you're talking about like, well, the C++ is a lot different, right? Because the map in C++ is basically a tree, a binary tree, right? It has you have to use comparators. An unordered map uses hashing, and you have to supply or depend on a specialization of the hash struct, that template. An unordered set is basically the same thing. Right, but why would anything be a multiple? If they're shared, you're saying? Like, because the way that translated in the way I'm thinking about it is that if two sides are being shared, maybe I'm not understanding. Are we talking about memory optimizations? Because I think I still am failing to explain. Kind of a side is just going to be just a way to query something. It's not actually going to be, I mean, maybe it will be. maybe when we define like the relationship between chunks being neighboring, we'll be able to find like I don't know. Haven't really decided. I can't right now I can't picture up, down, right, left, front, back. I can't picture I don't even think I need to write indices at this point. I can't picture a circumstance where sides would be shared. Because it feels like to me if the side is shared with another side, then it just means that there's no side at all, right? Because if two things are touching, then we don't want to render them. Oh, okay. I see the way you're thinking about this, though. I see the way you're thinking. You're thinking about the representation of a block being a combination of sides, where we can use like a bit mask to find. I see what you mean. What I'm trying to figure out is what that would entail in terms of the direction I was going. Right. It effectively saves you from you would have to figure out. Yeah, I have it. I'm gonna table this. I'm gonna table this because I get what I understand. I understand the approach. I'm not sure that what I was thinking about. I don't think it applies just yet. But you guys are gonna see something later, and you'll be like, "We told you should have used it this way," and that's fine. You guys can hit me with that. But basically what I want to do is just this for now. I just want to go through each, because otherwise we have to figure this stuff out at generation, right? You're not confusing me. I'm following you. I have like a direction that I want to take it, and if there's like, hey, this sucks, let's do this. I'm absolutely taking mental notes of all this stuff, but if it's not something that really caters to that direction immediately, I'm not saying I'm not willing to make changes to this, because this is literally just off the cuff. All of it is mostly. I guess what I'm saying is, let me get to what direction I'm going in, and then we can kind of have this like this back and forth, because without a doubt, what I'm going to build is not perfect, and it's actually going to probably have lots of holes in it. And all of the stuff you guys have been saying is like, they're good ideas. Like there's nothing. In fact, like if we were building this thing, they're way better ideas. But it's just for the clarity of the whole thing, I want to kind of build it out a little bit and then kind of relook it and then make changes. Because we're not really prototyping anything. I mean, we're literally just building as we go, sort of thing. Oh yeah, no, I mean, dude, you could save like everything. as a series of bits. I mean, it just gets, the only problem with doing that is you start bit packing and stuff like that, and you run out of flexibility in your design. But yeah, I mean, pack everything into bits. Yeah, we've done that. You end up having to, you have to create. So I've done that in practice. With, what the hell did we do this for? Like, we had a side by side game where you could. It was kind of like it wasn't Tetris, but it was like a Tetris type puzzle game where basically it was for like a social media thing, and we recorded your gameplay as a series of moves and whatnot. And then if your friend came along and wanted to play, it would basically pull one of the recorded games and play it back for you in real time and stuff. And so we did a lot of like bit packing with that, because I think it ended up being stored in the database as like just a binary blob. And so we basically, if we added any new moves or anything like that, we had to come up with like a pretty clever versioning system that could like convert. If it was an old style format that it pulled, it had to be able to convert it to the new style and stuff like that. So you end up with a scalability or flexibility problem, more or less. And the pros and cons start to look a little, well, I won't say it's a con, because you save a lot in the end. But so here we can do this. We can basically do this for our like lookup. I don't even think we need, I think we can use a const, actually. And we can just call this, what do we call this? This is a vector3 array. Side to direction. And then we can do vector3 dot unit y. And then front. Right? Typo. So all I really want to do, this is the entire point of all of this right now, is that I want to basically just start trying to move things into like a reusable space, right? So all of our directions, sides, unit vectors, normals, all that crap, we're going to reuse it constantly. We're going to just be using the same thing over and over. So all I'm really trying to do, this is more of an optimization technique, but it's also going to provide some APIs that like make it easy to, if I have a side and I need a direction, I don't have to write some conditional. I just ask a function and it gives me back what I need. So what I did with block, even though we've kind of already talked about the optimization there that will eventually be made. But yeah, like, so using a pack 2, right? So like Intels like to align on 2-byte alignment for Intels. I think that could be ancient. By default, CLR wise, I think they default to 4-byte alignment. Maybe not. Maybe it's 2-byte. I don't know. But anyway, so like right now we're doing Intel. But yeah, I mean, if I wanted to get into interrupt services and start looking at like different architectures and what byte align or what's faster alignment wise, then we can. But yeah, eventually it will all matter. It will all matter how we do this, because we're going to be pushing a lot of data around. So let's see what else. I don't know if I want to do aside from direction just because it's a float, but maybe we can do. I think we probably want to define. Let's define this. Let me see. Let me see how I've done this in the past, actually. Oh, I have a completely separate. You guys are going to see. Actually, hold on. This is create this. What did I have? I don't know if we'll need like an actual quad data structure or not. I don't think so. Okay, yeah, let's actually, you know what? Let's build one of these. Why not? I'm gonna create a geom package here. And let's add a struct. Let's add a quad. Was it a layout attribute? No, what was it? What was the name of that attribute? Damn it. Struct layout. Layout kind. What do we do? Sequential. Pack 2. Yeah, whatever. How do we do this? I wonder what the system generics vector 3 looks like. Is it worth a damn? What are we gonna call this? We could just call it VO. I'm really just considering making this guy. I guess it probably will end up being read only. Oh, nice. Saying the whole source. This is .NET Core? Oh man, it's got everything. Aggressive inlining. Clamp. lerp, transform, matrix 4x4, identity. Oh boy. Create translation, scale. Oh man, this reminds me of X and A. Probably is. Probably the same stuff. Nice. What the hell is big number? Big number. Big number buffer. Big int. Yeah, so it is netcore, I guess. Wow, this thing looks intense. I guess it probably is 64-bit for a language that doesn't support 64-bit. That's what I'm guessing. 64-bit primitive or whatever. I'm gonna do this. I'm gonna do this like this. This probably should go in a. This probably should go in a render, but we're not. We're gonna. Let's. What is it? Struct layout. We're gonna just create a UV vertex right now because we're gonna use it. It's gonna matter. We'll probably end up giving it a fancy hash function and some other stuff. What time is it? Got a little bit. We can just use vector 3 probably for storage because why not? Vertex. And then vector 2, we'll just call this UV. I think we can use getters like this though. Do we just want to X, Y, and Z? Yeah, never mind. And we'll just call this UV, and then we can probably have public. Just do the storage like this, I guess. What? I guess it doesn't really matter if we're gonna do that. It would save us nothing, actually. It would just be the same thing. So we'll just choose to use it and store it in a vector 3, so that we can do like operations on it without having to put it in one of them. I'm guessing eventually we will probably be glad that we have it stored. Like this. In case we need it, I guess. It's normally not a great reason. In case we need it isn't normally a very good reason to add something, but for our case, we will. Oops. Up. And then UV. Probably have one like this too. UV Vertex. Vector 3. Oh yeah, we'll change this. Vector 3 Vertex. Vector 2 UV. And have it set up like this. Then we'll have this guy just do its this thing. Where we pass this, or we pass the two creations to this, and then I just we could come back and add more later if we need them. 28 degrees. Is that Fahrenheit or centigrade? Yeah, I agree, man. Cold weather, hell to the no. Makes your hands all cold? Nope. So I'll explain. This resolve vertex is resolve vertex is going to be for, so the idea is that this guy is just relative. Like this will be like one of our side. What you'll see is we'll have a quad that contains these, right? Because they're not changing. Like we know that every block, like mathematically is the same. Like it's the same description of a block. So we don't have to generate or create this stuff every single time. So the idea is that we're just going for reuse here. We're going to create one of these things for every side of a block, right? We're basically a UV vertex that contains a UV and a vertex position are going to go into a structure. Then we're going to have a quad structure, and it's going to have 4 UV vertices and a normal, right? And then once you have the quad, then basically what we'll do from there is as we're iterating through each block in a chunk, we can say, give me a quad for the left side. And it's going to return this relative quad, and then we need to resolve. We basically will need to resolve the vertice in like world space later. So all this is going to do is it's going to return. Gotcha. Trying to figure out. We were talking about this. Basically, I get so pissed off at the U.S. or the American bullshit made up system of units, and that we don't use metric like a bunch of idiots. We won't even get started. But I always say that the only thing that makes sense, that makes more sense to me than the metric approaches with temperature. I just feel like Fahrenheit is just a much better unit. But that's it. Don't get me wrong, because everything else is totally fucked in terms of in terms of units. I actually didn't always think that, though. And I read some sort of research paper. It was basically the argument for Fahrenheit over Celsius. And if you can find that via Google or whatever, it was a fairly convincing argument. I mean, it definitely changed my opinion. Right, yeah. I mean, but that's, I hate it. I hate it. I hate how mathematically everything is very universal in the world, except for the U.S. has this blanket of bullshit laid over the top of it. Blanket of lies. And we grew up, the worst part is what it's done. Like it's like a form of brainwashing. Like, not really, but I've been conditioned to use the bullshit American measurement system. Let me find it. You're right. I agree. Kelvin. Yeah, but Kelvin is hardly a good system. Like, here's the thing. Is it's got to be I can't make this argument in a generic way because it doesn't apply to every single circumstance. But temperature feels more relevant. I don't blame the Brits for anything. I really need to find this article because there's a lot of like debates and stuff out there. But there was an article. It was written like 3 or 4 years ago, and man, oh my god, it was so compelling. It wasn't like this whole Fahrenheit's better than Celsius. I mean, it was like one of the best just approaches to a debate, I guess, or to proving their point in a way that was like, it's hard to read compelling research nowadays. I feel like there's so much noise out there. And that was just like one of the last things I remember reading that was amazing. So this resolve, all this is going to do basically is offset our, it's going to offset our UV vertex. I miss the syntax, the C++ syntax that lets you just return a thing and have it actually resolve to that type. But yeah, so new UV vertex here, and we'll do this inner vertex plus V. It's like our offset. And then our UVs don't change. So actually we can shorten this up because it's going to fit in our margin. So that's going to be our resolve or whatever. we have our vertex and UV. I don't think we need operators yet. We might. Yes, so yes, you can. So I haven't. I forgot that I ran into this last time. You're exactly right. You can, and you don't even have to create a new one to access the properties, right? So it's like a struct. So when you create it, it allocates it all in the stack. So you can write something like this. You could write this. Let's find it here. You can do this. You can do you can just write UV vertex, and then just do like vertex.x. We don't have setters, but if you pretend that we had a setter on our x here, we could do x equal 10. So yes, you can totally do that. Now this is the weird freaking thing, is that if I try to make, this blows my mind. If I try to make a default constructor that initializes, what is it saying? Structs cannot contain explicit parameterless constructors. So I think that the only way that, I don't know. I can't tell if it's saying that I can't have an explicit parameterless constructor because I don't initialize these things, or if it's saying I can't have one at all, period, no way in the world. But so yeah, so I saw this when I just Googled it, and I saw this, and this is around the same approach, but yeah, this is the same type of argument, but it's not done as this is more of a pointed. Fahrenheit is a better. I mean, the title is kind of, because at the end of the day, this stuff's about it's subjective. I mean, there it is. It's about what's preference, and there's an argument for both. I happen to be kind of completely turned by the precision, even though what I feel like makes the most metric units superior is the lack of required precision, if that makes sense. Like, you have these nice round whole numbers that are easily discernible into something meaningful, and then you have a foot, an inch. Like, what? I mean, like, you know what I mean? Like, it's crazy. But for some reason, Fahrenheit just feels, it didn't always seem like that to me. So I don't know. I guess it's a very tricky thing. It might have changed with me with my age. I'm not really sure, but but I love topics like that, because for the most part, I feel like you can talk about things like that without too much of a religious war going on. You know what I mean? Like, one thing you can't talk about is like spaces versus tabs, or next line versus same line, curly brackets, and I won't even comment. I mean, clearly you can see I kind of prefer this weird, but at work, we use a completely different convention than this. So I've kind of learned to navigate and not try not to care too much about it, but it's hard not to. Yeah, it's totally weird. It's totally weird. And I think scientifically, I still think the metric system probably. I still think that Celsius centigrade is superior. But with that being said, scientifically, Kelvin is superior to Celsius. I mean, it's like you have to look at the application. And I think in general weather, temperature, people walking around discussing weather, I think Fahrenheit gives you a better idea of what the weather feels like versus who cares when water boils or freezes. I just want to know how it feels outside. You know what I mean? Like in general use, I mean, this is the reason why there's various types of units, right? And I just feel like in every way possible, the metric system covers the scientific base and the general use base, like distance and size and mass and quantity and all that stuff. It just does such a good job at like temperature. I feel like it just, yeah, it's 273. Yeah. Don't get me wrong. It doesn't matter to me. That's the only reason I asked, because when I hear 28 degrees, that sounds miserable. That sounds below freezing. So we have this resolve. I don't think we're going to need anything other than this resolve right now. If we need to come back and add some like operator syntax sugar or something like that, we can. We'll probably need to do an equality and a hash function. But for now, I do have a question for you guys. I would really like a good, unique, well, I don't know if there's a unique one, but I would really like a solid hash function for vector position, for floating point positions. I mean, I can deal with it. I can hear either or and understand how it feels outside. But it's only because I forced myself to use the metric system where possible because I find it insanely convenient. But again, we live in a world, or I live in a country where it's miles and inches and feet and yards, and so you can't help but have to learn that as well. Okay. So our quad here, let's go back to our quad. So I'd just say basically on the opposite end of the spectrum, if you're looking at it from a non-scientific point of view, 0 is cold as shit and hot, and 100 is hot as shit. That's on the as shit scale. Yeah, so I've seen that. I've actually seen that hash code. I've used it. What is it doing? It's XORing what comes first? The XOR or the bit shift? The XOR, right? I mean, it will actually transform left to right. I think. I could be wrong. I don't know order operations for bitwise. Probably I should, but I don't. Quad. Yeah, I agree. I think there's lots of ways to do it. Most of them are probably going to have collisions. The only this becomes just a little bit of a ordeal, I guess, when you're trying to store block positions. Like, okay, so at some point in time, we'll do like some sort of, like if you have to scan a chunk for specific block positions that have X, Y, and Z properties, or we're doing like ambient occlusion or something like that. It's pretty normal to keep a set of blocks and be able to kind of, in our case, we don't want, I mean, we really don't want collisions between, you know, between the 0, 0, 0 and 16, 16, 16, or whatever our chunk dimensions are. We really don't want collisions in that range. So that's where where we'd have to derive our hash function would need to be somewhere that didn't collide in that range of values. But it would be nice if we could do like lots of values. But that's extra. Okay. Now that makes a lot more sense to me. Okay, so let's so this is what I've done. So my little struct objects are just little they're just data organization. I guess I wonder if actually this needs to be I don't know why this is always so difficult for me to think about. The way that properties act and work in C# is somewhat tricky for me, and I don't know why. They made this public. It shouldn't be. It shouldn't be. It should be pretty straightforward. And actually, I think in like one of the latter versions of C#, you don't even need the private set here. I think you can just initialize it. You can just make it a getter and then just initialize it. Because theoretically, like, I shouldn't need to write backing variables because of the way this stuff works. I can't do this either. Then probably I need a we'll have a normal. And can't you derive normals using vertex positions using like V3 minus VO or V1 minus VO, V3, V2 times V3, V2. Does that work out? Isn't that how you calculate? Thank you for that link assignment. Sorry, I'm kind of lingering here. I wanna. Do we even care? I kind of feel like we could just apply the normal. Again, we're not. This stuff is not going to be stored. This is not long-term storage that we're looking at. These are short. These are going to be short-lived objects that, or well, excuse me. We'll basically make one copy of kind of every type of quad we use for each block, right? And that's all we'll ever need. We'll just use this to copy around for mesh generation, and then they go away. Like they don't. These aren't like one of those. This is actually a really good candidate for a struct object because they don't have to. They don't have to survive long. They're quick-lived and over and done. So let's just, you know what? Let's just pass normal in. Even if we could derive them, I guess we're saving a little bit. But again, these are. We'll see if we can generate these on the fly, and we need to find more memory here. Look, I'm gonna comment here. I'm gonna add like a little note. Actually, yeah, we'll just put it. Why does it want to do this? We'll just do 2 of these. We'll do a to-do and put optimize out if necessary. VO, Vertex, V1, V2, V3. Normal. And V3 equals V3. I don't think we want too much more out of this as well. I think we just we have a normal. Maybe we should do. I'm not sure I like that method. Yeah, let's not do that. Let's not do a copy out. Let's just do. Eventually, we're gonna want this thing to be able to. We'll add like a convenience method that can write this to like a buffer. So we'll have like a write, and we'll supply a buffer by reference or something, and be able to write out the data in here to that buffer. There's this guy who works on our team, and he is awesome. I just got a review back from him, and he found like 1 million spelling errors. Oh, I love it, man. I can learn so much from people like that. He's so nitpicky. I love getting reviews back with just like the slightest detail. People that are so detail oriented. Primitive math functions. Dude, good for you, man. Like, shit. You're living the dream, man. I'm just kidding. That is the most boring stuff ever. And I've done tons of it. Every time I do it, I really like I have to meditate on it. Like, you have to do documentation and unit tests. Unit testing kind of has become a habit, just because every gig I've ever had requires, some level of unit testing. So it's become more habit. But documentation, man, other than like writing inline documentation for code, but actually going through, showing examples, having like a wiki for it and stuff like that, like really good documentation other than code documentation, it's really hard to write. You actually have to think about it. And like I dread it more than anything. I dread it. I have no problem admitting it either. I dread it. Dread it. This probably will belong in, and we'll have another one called quads. I'm going to call this quads, plural. I'm going to public static, this is just going to be a little helper utility here. Yeah, Doxygen is awesome. So our quads here, I think really all I want to do is just have like the most basic like sort of lookups. So really what we want is like I think we want to use our naming. This is going to be tricky again. We're going to end up with one of these like cardinal direction things. What are the const rules of C#? I'm not even familiar. I will actually refer to the documentation here, because I'm not really sure. Nice. Dude, this is awesome. I love that I can set this to dark now. I don't even know how I did. Oh, there it is. Theme. Sweet. So what are the rules? What are the rules about constants? Can I have an object that's a const? I'm guessing that I can. That doesn't tell me shit. Do I really have to go to the language spec for this? Really? I have to download it? What the Dude, if this is like a docx, I'm going to shit my pants. It is! Oh my god, it's a docx! This is going to, watch this. This is going to bark at me. Look at that. 2007 Office. Oh no, I don't want to activate. Cancel. I don't know why it wants me to activate this. This is the reason why it's 2007 is because this is the only one that I've owned ever. Where's const? See, this is why. I mean, don't get me wrong. Like, if I want to look through something, I will. For like, man, come on, please. Oh man, I don't want to read the language spec. I'm sorry. I wanted a fast answer here. Wait. Int C1. As long as, can you do this? Oh yeah, as long as it's another const, you can. Oh yeah. No, ReSharper is amazing. So why not? I need a. I've heard that with managed languages that const is actually not that big of a thing. Like that it's not semantically like, I mean, let me just backtrack here, because really and truly, when you hear const, people like to, if people know C++, then they like to relate it to the const in C++ because they feel the semantics there are more stable. But you know, C++ lets you do whatever. You can cast away the const if you want to and do a bunch of other crazy shit. But I need to understand semantically what it means to be const versus static read only. I think const, at least semantically, it implies static. I think that much is obvious. But where we get into the differences, I want to know what const read only variables, you can still read them from non-const, right? I don't really know, to be honest. I'm with you, Colt. I don't know semantically what the difference is. I mean, we could crack it open in the disassembler and see what the IR is for const versus, but I'm guessing there's some IR command like define const or something. But I think const, you may not, I don't think you can modify the object. Stack Overflow to the rescue. Let's read it together, shall we? Are implicitly static. Okay. That's, so we've confirmed that. You use a class name. Okay. I mean, I think I would have. Maybe not, though. So basically what it's saying is that if you compile a library with const, you have to imagine it as being like a find and replace sort of thing, where that library is always going to have something defined as the thing that it was defined as, versus the static read only, which can, I guess, be modified to mold, or it can be modified, I guess, depending on how the library is. It's not that confusing. I'm doing probably a bad job. The guy in the Stack Overflow post probably explains it in a way better way, but I understand conceptually what it's talking about. Don't define constants unless you want constant, unless like if you have to change a constant, you have to recompile your libraries, is essentially what it's saying. And that's fine with me. That's what I want to do. Although I'm guessing that this is going to end up being a static read only. Yeah, look. You cannot define the type quad as cannot be declared as a const. Show potential fixes. Nothing. That's hilarious. So yeah, it tells me to Tells you to make it. That's fine. That's fine. Oh, dude, const expression is so awesome. It changes so much about just convention and practice in C++, and I love it. Now, you could do some crazy shit with it, to be fair, but in general, I mean, just as a general language construct, it's so powerful for what it can do to transform like really ugly ass initialization stuff in C++, which is typically always the big annoyance. I mean, there are lots of annoyances, but that almost none of them have to do with you know, I guess the language itself, but it's more about the portability of the language. Because everything's portable, it just, a lot of it depends on weird library issues that, you know, no one ever wants to really screw around with. So let's see here. So I guess our quad definitions are going to be vector 3.
Come on, kill me.
Thanks. Thank you for the follow there. I appreciate it. We'll use unit Y for the normal. And then UV vertex. We'll define this as what, 0, 1, 0, 0, 0. This is just going to be our order, right? Because we want to be able to draw things here in order. And this is 1, 1, 0, 0, 1. And this is 0, 1, 1, 1, 0. So remember X, Y, Z, UV. And this is UV vertex. 1, 1, 1, 1, 1. I should probably, this is going to be long and annoying. But I'm going to literally just copy these straight from what I have in my notes here. But I'm probably just going to, I need a template. I need a template here. And I'll probably just actually just copy this out right here. Bottom is 1, 0, 0, 0, 1. 0, 0, 0, 1. And 0, 0, 1, 1, 0. Sorry, this is 1, 0, 1. Yep. Okay. Yeah, I'm the same way. I did it for like 5 years. And I'm really happy that I'm... Well, there are parts of it I miss. But not the... not the exhaustion of writing C++ code. That's for sure. Right. We'll call this... This will be our right side as well. Positive normal. Yeah, this is annoying, but it's like once we do this, right, we have our template for all remaining. Maybe I'll do it like this. 0, 0. Oh, right is a fun one because I think it actually, yeah, right is the positive ones are fun. I think because they all, oh, let's see, this is What's really not fun is where you have to figure this out from scratch, because that's what I did the first time and it was awful. 0, 1, 0. Yeah, this one is actually like true to form. Made this one left. Oh, I'm still stuck at C99. I'll be honest, I didn't even know that C99 had a follow up to it. I mean, I guess did they have to update the C standard to support the new C++ standard? Is that kind of how that works? Like, I know the C++ standard like was stagnant for what, 11 years or something stupid. They had like revisions in between, but I don't think they had any in betweens. Right? Like there was always like this 0, 1 0, 0, 1, 0, 1. Oops. This is way wrong. And all zeros. It's left. And this is X actually. Okay. Quad. This will be front. Yeah, structs in C++, basically the only difference, they are fundamentally the same representation of data. The only difference is that a struct has a default accessor of public. So if you don't explicitly express private in a struct, it will always be public, whereas with a class it's always private unless explicitly expressed as public. It's the only difference. So, also static is a lot different. And truthfully, like C++ tries to, they can't completely get rid of it, but they try to not, I won't say replace, but they try to re-express one of the variations that people use static in with anonymous namespaces, which is basically you just have a variable that needs to be scoped to the compilation unit. And that's where you would use anonymous namespace, or you could use static as for backwards compatibility, but static can be tricky in terms of what it means. And so they're C++ standards trying to like push conventions that get people using static and anonymous namespaces, and so you don't have these double meanings for static. Whereas in C, it just really means one thing. So we're at our front. What's our front? Front's gonna be here. Look, I gotta copy this again because I don't want to fill in the blanks. This is gonna be a front is gonna be positive Z. 0, 0, 1 and 1, 1. I'm gonna make a typo here, and we're not gonna figure it out till way later. Shit. I just thought about that. That is going to be, I'm going to have to pay a little bit more attention, I think. I think these are actually, are these identical? No, they're not. They're all switching around. 1101. Yep. 10110. Oh, nope, made a typo. 10110. And then all ones. Shoo! Caught it. Caught it before it was a nightmare. And then back. It's going to be a negative unit Z. All zeros. 0, 1, 0, 0, 1. 0, 0, 1, 0. And then 1, 1, 0, 1, 1. So the UVs always alternate 0, 0, 0, 1, 1, 0, 1, 1. What we're doing is just basically we're keeping the UVs the same order. Like, see, this is wrong, I'm pretty sure. I think I forgot. This is a typo for sure. So like left, this needs to be 1, 1. So it's an easy way to check that I've made at least a UV based. Yeah, actually, this is way wrong. Hold on, where was I reading this? All zeros. 1, 0, 1. That one, second one's right. 0, 1, 0. And then this last one, it looks like I just left it out. Is 0, 1, 1. Let's make sure 0, 1. Yep. Okay. And then we can just make sure we do positive, negative Z, positive, negative X, positive, negative Y. Okay. I love Yeah, what is it? What is the second reason? I'm trying to think. It's more of a static is basically a static is like is a if you use it in a class, if you use static in a class, it's basically the same way you would assume that static works in like a managed language, right? Or another language, is that you can access that method statically, right? Does it have any other meanings? I just always feel like I use it one way and one way only, and I don't use it the other way. Right. So class specific, right? It's kind of like extern is to namespaces, right? I think C++, I think any namespace defined function is implicitly extern. Okay, static variable, only one exists, right? And that's bad because you can collide very easily versus compilation unit scoped variables, which don't collide with anything else outside of the compilation unit, and that's why they're better. Well, that's why they're better without quotes. let's just be real here. They're better. Okay, so we're just gonna hope that this is right. If it's not, then we will have to, in some way, shape, or form, revisit. This is basically our geometry that's going to be required for each side of a voxel, of a bloxel, we'll say. This is defining pretty much a cube, the cube sides, in terms of numbers only versus these aren't actually building out anything. What we will do, though, is as we're traversing and building the mesh, we'll take the position of a block. We'll examine, properties. Hopefully, in a lot of cases, we'll already know what sides we'll need to render and stuff like that. And basically, from all of that information about the block, we'll be able to determine, hey, look, take the front or the right sides, apply them to the position of the block. Basically, offset this generic template of a quad. Let's offset everything by the position of the block and add it to kind of this grand VAO, vertex array object, or vertex buffer, and then we're gonna we'll pass that to our rendering system, and it will render and then we can throw it away and move on to the next thing. Or maybe we shouldn't throw it away. But we'll get into pooling and stuff like that later, because ultimately we don't want to throw anything away. We just want to use like a giant vertex pool. And we'll just, as we are looking at each thing, we'll pull new data. Or sorry, we'll just overwrite the old data and we'll upload the new stuff, instead of having to create and copy and do all that other amazingly expensive stuff. I think we're probably at a good stopping point for today. I don't want to go too much longer because I need to make probably another cup of coffee and kind of review some things for work today. But let's keep it here. We'll come back to this. Actually, let's go ahead. Let me go ahead and get this stuff started. I'm gonna call this side. No, wrong namespace. Where'd it go? There it is. Side, and we'll make it a byte. And I think at some point we're going to take the advice of making these flags, but for right now let's make it just an index that we can keep it. We can kind of keep it simple here. So let's we'll just do up. Wow. New keyboard. Why is that key not? I was about to say, is that the key that I had coffee in? And then I think once you kind of establish this, I'm pretty sure that it will just follow this order: up, down, right, left, front, back. We can print them to be sure, but right? Can't we do that? Isn't that a doable thing here? If like I go up here and I do like is there names? Whoa. That's the reason I hated this keyboard, because it has I always hit the insert key. What is it? Nums? A num? Get names. Type of side. Wait, can I get the value of it too? Wait, hold on. Let me think about this. Oh, we want to get values. Let's do that. Wait, can I do? Is there a get value? Okay, let's just do this. We'll just do values. I wonder what that's an array of. Is that an array of side, or is that an array of... I hope it maintains order for both of them. Let's just do names at length. So an array, I guess. And then let's just dump it out. We could probably just use the debugger, but too late now. Names I. Value. Use I. Heyo! And probably, what's it mad about? Wait, what? Get value? Yikes. What is this, like? Wow. Is this just like a generic array? Ugh. Gross. Get value. Nasty. Okay. It does. It just continues the increment. Neato. Managed languages. For a C++ programmer, I'm telling you, managed languages, there's just things about them that feel so good. Like not having to worry so much about the design of your API and how it does its little dance with memory management. And then also you just can write less code and do more, and that's nice. But the one thing it does do is it will keep you up at night wondering about how everything's working on the inside, and that's the hardest thing to overlook. Okay. So, we got our side. We'll just leave it at that. And then I wanted one more, I think, that I was going to call direction. We'll call it directions. Let's use a little plural form here. And this guy will be a public static as well. And this is going to just have, I think, what did we say we wanted to do? I was like going to do something like that. Yes. Yes. I don't think we're going to be able to do that. It's not going to be able to be a const either. Maybe it can be. It can't be. Right? Can't do that. You can't do that. Mainly, I bet you these are statics. Read only. Yeah, that's why. They'd have to be a const in order to do this. So we'll do static read only. So I don't think we're going to be done here necessarily with this, but what we can do is we can do like and then pass in a side. Oh, I got way too many squigglies. Oh. And then we could just return. Will it just, yeah, I didn't think so. It's always got to be complicated here. Oh, static. So we'll do stuff like that. We'll do stuff like this. I think this is where I want to end it today. We had a lot of reusable geometry type approaches to this. I mean, what this is going to give us in the long run is instead of having to go through and draw like a cube every time we want to draw a block, right? I mean, there's clear inefficiencies there, like overdrawing something, not sharing vertices. There are lots of problems. We're gonna see some of the trade-offs later. You're gonna see explicitly what I've done here with this UV vertex is, we've kind of prevented the ability to share vertices in that way because we're not sharing the UV for a vertex. by splitting up in the quad. So there are like optimizations and things that we can look at later and how to share, maximize how much we share of that data, especially when we start creating like batches of it. As we're generating the mesh, we can really focus on how to reduce the amount of data we're pushing to the GPU and make optimizations that way. We can look at a multi-threaded approach. We definitely need to pool all the geometry data that we're using so that we can reuse it. In general, that's kind of the direction we're moving. And we aren't quite into like world generation and that sort of stuff and stitching everything together and then focusing on like, once we get there, we'll be looking at stuff like updating and how updates propagate. So if I change a block on chunk X, what happens to everything else. Clearly, if you remove a block, then the blocks that were next to it need to somehow change, right? They need to render and so that they're displayed versus hidden away. You have to kind of propagate these changes. And the same thing applies for chunk boundaries. If I change a block that's on a chunk boundary, the chunk next to it needs to actually know that the neighboring block changed, and then it needs to also update and re-render. That sort of stuff. So we'll get into that, but for right now, we're just, we're keeping it fairly clear. We're not doing any sort of over optimization. We're just saying, look, we're going to define the basic structures, our mesh data for generating a chunk, generating the geometry for a chunk, and then we will take our block and chunk configurations in terms of our data structures, and we need to eventually be able to take all of that reproducible data and generate full meshes that we can then pass to our renderer. So that's what we'll do probably starting tomorrow. Probably be back tomorrow. Thanks again for everybody's participation. I love days like this when everyone's talking. So thanks again, and we will hopefully see you back here tomorrow. Anyway, take care, guys.